Hey guys, I wanted to point out a mistake I made in my concave Earth video. It was the Milky Way. I had it tilted incorrectly. It's actually, in my animation, it's going around the celestial equator. And later I found out that's not the case. It actually tilts at a 60-degree angle. So if you look up in the sky, you see the Milky Way. Now keep in mind, in the concave Earth, the Milky Way is not a spiral galaxy. This is reality. You're not in a little insignificant dot out in a vast, endless universe. No, that's not it. The Milky Way galaxy serves a very important function. Okay, remember in Scripture it says that the stars are created for signs and seasons. Seasons. The Milky Way actually, I'll get to that a little bit later, but it actually governs the direction of the sun. It's what it is. It's a band. It's a ring or a band or a governor or a rudder that's wrapped around the celestial sphere. See, there's my correction of the animation. It's tilted at 60 degrees like that, and it governs the direction of the sun, whether the sun wants to go north or south laterally. And what I did was I did some investigation into the Milky Way galaxy, and it turns out that from 1990, I believe, to 1993 to 2009, there was, I guess NASA said that they had the Ulysses satellite that actually, they say it orbited the sun. Okay, well, no, I don't believe it orbited the sun. They think the sun is 93 million miles away. It's not that far away, guys. It's very close. It's within the Earth, okay? And as far as like satellites go, if you know anything about how they're not really up there, they can't get past the thermosphere because it's 2,000 degrees Celsius. Yeah. They usually, what they do is they'll mount some kind of apparatus, some kind of surveilling camera apparatus to the glass sky at 100 kilometers high, and then you can shoot the sky, you can take pictures of the sky, or they might have a very low orbiting satellite that's just going skimming above the glass. But if you get any higher than 120, 140 kilometers, the temperature increases so greatly you wouldn't survive. And then they try to tell you, well, the air molecules are too far apart. No, that's baloney. That just doesn't work that way, guys. But anyway, the Ulysses satellite, I was doing some research and I found out that it says that here, observations of the sun's poles are sensitive to the tilt of the sun's rotation axis relative to the ecliptic plane. What does that mean? Observations of the sun's poles are sensitive to the tilt. Okay, and it says it reverses every 6 months. See, this is the key indicator, because when I looked at the band around the celestial sphere, I thought it's got to be doing something every 6 months. It's got to be serving some kind of purpose, some kind of function every 6 months, because the sun is going around the celestial sphere, but it's going through the band every 6 months. So something's happening every 6 months with the Milky Way galaxy. Not a galaxy. Well, it's not a galaxy. It's a band. Correct myself there. So yeah, I think what's going on when they took the observation with the Ulysses probe, they probably had two different apparatuses mounted at very high latitudes. This is my theory about what they did. This is my guess, basically. So this diagram, it shows a concave Earth reality in which we're living in, because light curves within the Earth. It's difficult to see the poles, the top and bottom of the sun, because like if you're standing anywhere inside the surface of the Earth, let's say you're standing here at the equator, when you always look up at the sky, you're always looking at the front of the sun. If you're like even way down here in the southern region, the way your eye works, it's like an endoscope, it's like fiber optics. You're always looking at the face of the celestial sun, of the celestial sphere. The moon's a little bit lower, so you see a little bit more of the edges of the moon, but not much. But the higher you go, especially the sun, that's why we always see the front of the sun, because light curves like an endoscope, like a fiber optic endoscope. So the Ulysses satellite, they probably, this is my guess, they simply attached cameras. If you watched, I made a video about attaching cameras to the sky, and there's actually artifacts. Google and Microsoft, they show, space programs, they show there's artifacts of apparatuses up in the sky. And so they probably, what they did is they attached something here on the glass sky in the southern region to monitor the southern pole. Now it's not really a pole, because I don't believe the sun is a sphere. I believe it's a half sphere. It's kind of like a kettle drum. because I told you before, I had a vision of the back of the sun. The back of the sun had these parallel rays hitting the diameter of the sun, indicating that it was a flat surface, and which also testifies to the electricity of the sun. If you understand anything about what they talk about the electricity of the sun, whether it's Wal Thornhill or Donald Scott, they say that the sun is electric. This is very accurate too, because it flies in the face of mainstream solar research, which is all baloney. Okay, so in the mainstream, the standard model, they say that the sun has a core and there's convection going on. There's no indication of convection. And I can show you this video later. I'll give you a link to it later. But it shows that there's so many problems with the sun being this nuclear ball with a core. Convection doesn't happen that way, where they have the granules on the photosphere. They just invent this stuff up as they go, because that's not the truth about the sun. The sun is electric. The sun is hollow. Remember Eric Dollard? He said those black holes in the sun, they're indicative of the sun being hollow. And then he also said that the sun is getting its energy from a different source, a different dimension. And I'll go into that later too. I say it's the pyramid in the middle of the earth. That is the source. That's the anode to the cathode. Okay, you have an electric current going. You have a circuitry you're connecting, going from the top of the pyramid to the back of the sun, and the sun is revolving around the inside of the earth. So with these probes, this is how I believe what they did is in the south, during the summertime when the sun is farthest away, they get a better angle of the south side of the sun. Same thing in the north. If you're up here, during the winter solstice, the sun is down here, you get a better angle of the north pole of the sun during the winter time. And so that's how I think that is what's going on. I'm going to get into the different velocity, rotation, speed, the different velocities of the sidereal rotation of the celestial sphere and the solar rotation of the sun. Now, they will tell you there's an apparent difference, the heliocentrists, they will tell you there's an apparent different rotation because of how the Earth spins relative to the background of the stars as it's orbiting the sun in different positions away from the sun. But that's not true. There's actually, just how how they say there's an apparent retrograde motion to the planets when there actually is a literal retrograde within the concave Earth due to magnetism, there's also a literal difference in velocity between the celestial sphere and the sun. The celestial sphere is going slightly faster than the sun, 4 minutes faster. The sun is 24 hours, the celestial sphere is 23 hours and 56 minutes and 4 seconds or something like that. So going back here, there's an animation I made of the sun, of the kettle drum shaped sun. You're looking at it initially from the front, and then I'm turning and panning. That's the vision I saw. Actually, the vision I saw was more front on or back on. It wasn't angled like that, but that's how I saw the sun. And makes sense. So you have this energy, this electric current. It's finishing the current, going from father to son. It's kind of interesting how we call it the sun, and how we call the pyramid, or how I call the pyramid, the father of lights in James chapter 1 verse 17. So the actual function of the Milky Way band now you look here, okay, I have this labeled here. When the sun is at its highest, its crest in the summer solstice, it's going to start turning. Remember how they told you the tilt angle relative to the ecliptic? So the sun is going to start turning counterclockwise, going south now, as it passes through the Milky Way. The Milky Way steers it somehow. Must be like, what I think is this whole celestial sphere is pretty much dark and very thick clouds. The Bible says thick clouds of the sky, or dark water and thick clouds. And so I think that Milky Way band is a little bit thinner. That's why we see light coming through. And so there must be some kind of change with the thickness or the thinness of that light, and is changing the rotation of the sun slightly. It's just the bank angle, I guess you would call it, and it's starting to turn down like that. And so Because of the different rotational speeds, the sun is a little bit slower. That's how the sun goes through the 12 constellations. Okay, you have the ecliptic here, and then you have the celestial equator. That's the green stripe, and then the white stripe is the 60-degree band of the Milky Way. It's a band. It's not a galaxy. It has a function. So when it gets down to the south during the winter solstice, it starts turning. The band causes the sun to turn up back clockwise again. So it's a governor. It has a purpose. It's a direction. Everything works. Everything has function within the concave Earth. You guys, it's once you understand it, once you have that foundational understanding of the concave Earth, everything makes perfect sense. Well, almost everything, but that's the reality in which we live, guys. The Milky Way band. Stop calling it a galaxy. It's not a galaxy. The Milky Way band, the different velocities between the sidereal and the sun. Okay, it's not an apparent difference in velocity. It's real. The sun is electric. I recommend you watching a video by Donald Scott. Of course, he doesn't understand of the concave Earth, so he still has a couple problems with his understanding of the sun. But the sun has a dark side. Watch that nova. There's a nova video about how they talk about the bullshit. How they talk about, oh, there's helioseismology going on in the core of the sun, and then there's convection. There's convection going on. Well, no. Donald Scott talks about how there's a temperature minimum in the chromosphere. So you got the sun. You got the surface of the sun would be the photosphere, and then the chromosphere, and then the corona. And it doesn't work that way. He's talking about how a nuclear reactor doesn't work that way. There can't be a temperature decrease and then all of a sudden an increase. But and then of course CMEs I think happen a lot slower within the concave Earth. I mean, they're talking they're saying they get really fast, like up to 1 million miles an hour. Well, that's because you're already thinking that the sun is 93 million miles away. It's not. So everything is within the Earth. Everything's happening, as far as CMEs, it's happening slower. Alright. I think that about does it for this video. See, did I miss anything? No. Talk to you later.